In this lesson, we'll be talking about quadratic equations in one variable. So, first off, just simply what we mean for a quadratic equation is it's of the form ax squared plus bx plus c equals 0. Very important for a quadratic equation is we need to be able to write it so that 0 is on one side of the equation. And this is the methods that we do for the majority of the times that we solve these. Another thing to bring up is that a can't be 0, because if the x squared term were gone, this wouldn't really be quadratic, we'd call it linear. So, with that said, let's go ahead and jump right into trying to solve some of these. So one of the strategies that we use is the strategy of simply factoring and setting each one equal to 0. So for this one, we can just factor an x out of the equation. And then what we do is we set each term equal to 0. So x can be 0, or the other factor, 3x minus 10, is equal to 0. Well, here's one of our solutions right off the bat. For the other one, we'll add 10 to both sides, and then we'll divide by 3 to get 10/3 for our other solution. Next example. Remember, for these, you need to get it equal to 0 first. So the first thing I'll do is subtract 5x from both sides. Note that nothing cancels here, we just write it as x squared minus 5x plus 4 equals 0. And again, this is where those factoring techniques we talked about come in very useful. You need to know how to factor this. You find two numbers that multiply to 4 and add to -5. And those numbers are -4 and -1. So now we just set each one equal to 0. X minus 4 equals 0, or x minus 1 equals 0. That gives us x equals 4 as one solution, and x equals 1 as another solution. Next example. First thing I'll do is just go ahead and subtract 2 from both sides. Again, nothing combines. We get x squared plus 7/2 x minus 2 equals 0. And you're going to have a very hard time factoring this if you leave it this way. So let's next multiply by 2 to get rid of any denominator. We get 2x squared plus 7x minus 4 equals 0. Now we just need to figure out, what does this factor to? Now I'll let you go through and try it, so feel free to pause the video if you want to try this and factor it yourself, but I'm going to use the trial and error method for mine. So I know that 2x squared is going to be 2x and x. And then what I need to do is find two numbers that multiply to -4, and when I do all the FOIL stuff, I get 7. So my mind is going to 8. If I put the -4 here, or maybe make it a +4, then I would get an 8, and the other term would be a 1, and that does it. However, the 7 is positive, so let me put the plus on the 4 and the minus on the 1, and now as you can see, I would get 2x squared, 8x and 1x, which makes the 7x, because this one's negative, and the -4. So, that's the way I factored it, but if you have another way, that way is fine too. So we have 2x minus 1 equals 0, or x plus 4 equals 0. X equals -4. And the left side we get 2x equals 1 by adding 1 to both sides. So x is equal to 1/2. Solves this one. Those are my two solutions for this particular equation. That's the method of using factoring to solve an equation. Here's another method that we can do. This is one that you want to make sure that you don't forget one very important step, no matter how far you go in your mathematical career. If you get something squared on one side and a number on the other, you are welcome to take the square root of both sides to solve this problem. However, very, very important, you must include a plus or minus every time you take a square root like that. If we don't, it ends up not working at all. We'll lose a solution. We call this the square root property, and it's helpful anytime you have something squared on one side and a number on the other. So, We use this method anytime we see a problem where you get a squared term and no other terms with x's in them. So like in this example, we've just got an x squared and a 9. So let's solve this problem. To do so, what we need to do is we'll start out by subtracting 9 from both sides just to get our constant terms on the same side. We get x squared equals negative 9, and so now we'll take the square root of both sides. And again, when I do that, I must have a plus or minus whenever I take the square root of both sides. That leaves me with just an x on the left side, and plus or minus the square root of negative 9. However, that's the square root of negative 9. And so far in this course, we have just said that it is not possible to take the square root of a negative number. Yes, there are some techniques, and we'll study them later, for dealing with square roots of negative numbers, but at the moment, I'm just going to say no solution immediately. It's just not possible to get a value out of this expression. At least not a real value. Next example. Now, these two examples look a little bit more complicated than the last one, but this really is the same thing. You've got something squared, and you've got numbers. You can make this problem a lot harder for yourself if you were to multiply everything out and end up with a new equation. But if we use the fact that it's already squared, we can solve this pretty quickly. So again, I'm going to get my constants on one side first. And I get x plus 3 squared is equal to 4. Now I'll take the square root of both sides, just like I did last time. And remember, whenever you do that, you need a plus or minus when you take the square root of both sides. On the left side, we just get x plus 3. And on the right side, we get plus or minus, and you guys know the square root of 4. That's 2. So this is coming along where we want it to be, but I need to get x by itself. So what I'm going to do is I'm actually going to subtract 3 from both sides. And where I wrote this other minus 3 is sort of deliberate. Unfortunately, with this being a plus or minus 2, I can't combine the 2 with the negative 3 in the usual sense. I really need to treat this as two separate problems. So here's what I'm actually going to write. I'm going to write negative 3 plus or minus 2. And this still isn't exactly desirable, but this gets me along the right path. What I now have is x is equal to negative 3. And remember, this symbol is read plus or minus. So this means negative 3 plus 2, or negative 3 minus 2. So we get x equals negative 1 is one solution, and x equals negative 5 is the other solution. Let's do another one like this. So we've got the expression so that the square is on the left side already, and the number is on the right side by itself. So I'm going to immediately start out by going ahead and taking a square root of both sides, and again I need my plus or minus when I take the square root of both sides. So I'm left with 2x minus 7 equals plus or minus the square root of 5. So now I just want to get x by itself. So let's add 7 to both sides. And again, there's no combining these. I just have really 2x equals 7 plus or minus the square root of 5. And then if I want to finish getting x by itself, I'll divide by 2. And that gives me the solution x equals 7 plus or minus the square root of 5 over 2. Now I'm going to call this one my final answer, because this really doesn't simplify any further. You could plug these in a calculator and find 7 plus the square root of 5 over 2, or 7 minus the square root of 5 over 2 as your solutions, but I would rather avoid the decimals, so we'll stick with what we have here. But by the way, you might look at this and say, well, that's an awfully terrible answer, but if you've ever used the quadratic formula before, you probably recognize this as probably the answers that come out of some quadratic equations. Here's the quadratic formula. If you've got an equation for ax squared plus bx plus c, you just simply identify The first coefficient is a, the second coefficient is b, and the third one is c. And from that, we might need to use what we call the quadratic formula, because factoring's not easy, and you don't have a squared term that you can get by itself either. So, here is the quadratic formula. The quadratic formula, you've seen it before, but it's one that you have to memorize. You need to spend some time making sure that you know the quadratic formula by heart. You will need it for the rest of your mathematical careers. So learn it carefully. Learn a song if you want to. I'm sure there's plenty of videos on YouTube that'll give you a quadratic formula song to get stuck in your head. The quadratic formula is a nice formula. It's derived from something called completing the square. In this course, we won't do completing the square, but you might need it for a couple of problems that you run into in the future. In those future classes, they'll mention it if you need it. Another thing about the quadratic formula is the inside of this square root has some special properties, and we call this the discriminant of the quadratic function. And so the part under the square root gives us the power to tell us how many solutions we have to that quadratic equation. So if this number is positive, we know that the square root is going to be just some value, which is usable. If the inside happens to be 0, then what we get is the square root of 0 is 0, and this whole term disappears, meaning we really only get one solution, although technically it's repeated. If this number is less than 0, then we have the square root of a negative number, which we know is not a real number. And then finally, just one more note on if this is positive. If this number is positive and it happens to be a perfect square, meaning you can take its square root evenly, then it's actually possible that the polynomial could have been solved by factoring instead of the quadratic formula. Let's solve by using the quadratic formula. Again, very first rule is you have to get it equal to 0. So the first thing I'm going to do is subtract 6x from both sides. I get 2x squared plus 2x minus 3 equals 0. So a is 2, b is 2, and c is negative 3. All we have to do now is just plug it into the correct formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. That's the quadratic formula. So now let's simplify it. I get a negative 2. On the inside I have 4. And I've got 2 negatives here, so this is going to become a plus. 4 times 2 is 8. 8 times 3 is 24. And I have this all over 4. So I get negative 2 plus or minus the square root of 28 over 4. So let me point something out. 28 is the square root of 4 times 7, right? So I can break this down and get negative 2 plus or minus 2 square root of 7 divided by 4. And now I see I can cancel out a common factor of 2. I get a 1, and the 4 becomes a 2. So I get negative 1 plus or minus the square root of 7, all divided by 2. And that is my final answer to this problem. So sometimes once we use the quadratic formula, we can reduce the square root, which makes it possible to reduce the whole fraction overall. Sometimes the denominator goes away completely. Next example. A is 1, B is 4, and C is 13. We get negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So let's see, we get 4 squared is 16. 4 times 1 times 13 is 52, all over 2. So this is negative 4 plus or minus the square root of, looks like, negative 36 all over 2. And as soon as I see this negative 36 inside the square root, I can immediately stop and say there is no solution. Again, we cannot take the square root of a negative number, so we stop immediately right there.